This is a version of a motorized lab jack using a stepper motor. There's two controls on the stepper motor. There's a clockwise direction, and I've got this hooked up to go upward in the clockwise direction. And if you press the clockwise button again, it stops. Press it again, it keeps moving. There's also a stop button. But we're going to go up. This is about approximately the max height that it needs to go to be into 50.3 focal length. I'm going to hit the counterclockwise. Now it's going down. So if you'll notice, the lab jack has been modified. I'm only using the top half of the lab jack. I've removed the bottom half. And the reason the bottom half was removed was so that I could allow the stepper motor to sit on the base of the laser case. The green bracket that's around the motor only supports it so that it doesn't do anti-rotation from any torque. If you'll notice the motor, when I go up, the front part of the motor that's close to the green bracket, you'll notice that gap getting smaller. And the reason for that is the lead screw moves outward as the lab jack goes up. So right now we're again going up. There's no built-in stops on this lab jack yet. I plan to just put a gauge on the side that marks the max up and the max down. You'll notice that the motor is retreating into the C-shaped bracket. This is about the maximum height that's needed for the laser to work properly. Again, I'm going to press the stop button now because there is a stop button. This particular unit, I find that I'm running it at about a 20 unit speed. I find that's really good for me because I could put a focal length gauge in place and I can actually stop it before the focal length crashes into the laser head. So it's, again, pretty good speed. So this is, again, I'm going to go downward by pressing the counterclockwise. I can stop it. You can notice that by clicking the button real quick, it does a very small movement. The green parts below the jack are 3D printed parts which I designed so that they position the lead screw in line with the center of the stepper motor. Okay, now we're down all the way. This is a view of the front of the lab jack sitting in the support brackets that replace the bottom half. You'll notice that there's two gaps between the outer links and the center stationary part that the lead screw is pulling backwards. That gap sits, there's a plastic part that sits within the gap to help hold it and allow it to go up and down in a straight motion. This is now the lab jack pulling back. You'll notice it's going up and it's just riding within the gaps. Go down, I can stop it. Okay. So I'm going to stop it now. Now we're going to kind of look at the top. I put a hole in the center, and the green part that you see sticking out basically holds a nut in place. Helps me locate the nut to the center of the hole, so when I put the top or the base plate back in, it'll align itself properly. This is the motor controller. It is an all-in-one where it has the control circuit and the drivers needed to drive the stepper motor. All you need to do is plug in a 12-volt power supply. The stepper motor that I'm using is up to 2 amps. I'm currently using a 1 amp power supply, which seems to drive the motor correctly. There's a counterclockwise button. There's a clockwise button. There's a stop button and a rotary switch to change the speed. As I say, currently I have it approximately 20 units, and that's where I run it. It seems to be a speed that meets my needs.